Welcome to part 2 of a video where we're attempting to build a automated robot fleet. Okay, so in this video we're gonna still keep it quite simple. Our goal at the end of this, at least as our first prototype, would simply to build our tank robot to face a specific direction. So this direction is dynamic, it can be given to it via the software, and yeah, so we can actually send a couple of commands such as turn left, turn right, drive forward, and then look at a specific GPS location. That's the next step, but currently we're just doing a test of looking at the compass direction. So currently in this video, as you can see, it is attempting to reach, I think it's about 275 degrees, essentially looking slightly a little bit off north. And yeah, this is, so we'll go through the steps to just get to this point, because there's some unknowns in this project, and we'll take it step by step to see what we can, what are the limitations of each, and yeah, let's see if we can get to a final prototype. Okay, and it's also worth mentioning that we're currently controlling the robot through the internet. So essentially, there's a server, and we're giving a command to the server, and the robot is getting the command from the server. So this robot could be currently operating anywhere essentially in the world. When starting a project like this, you can either start at the side of things, let's say what you know already. So let's say if you've already worked with GPS and motor controllers and all of that, you can get that implemented and coded and so. But in my view, it is better to start with the unknowns and the uncertainties and the possibly hard parts, because those things might affect the easy parts that you already know how to work with. So in this case, because the robot runs on this tank, the first thing is to understand the tank, essentially the tank chassis. So, okay, so this is not the exact same tank that we sell on our website. That's actually why I'm using this tank, is because it doesn't have a nice spring-loaded pulleys on the tracks itself. So, I didn't feel comfortable to sell this, so that's why we're using the tank. So, okay, now, from that point of view, I don't know what the motor requirements are and what the power ratings are, and there's very little information about this tank available. So the first thing to do is to hook up a power supply and test two things specifically. Number one, what is the minimum power when it starts to turn the motors? Obviously you will still want to have a little bit of torque, and so it shouldn't just turn the motors and not be able to turn itself when it's on its own weight. And the second thing is to see what the maximum is that you want to supply. And the maximum might be a little bit harder to determine, but one easy way you can determine it, or at least my way I determined it, would be to say, look at the amperage or the current being drawn by the motors as you increase the voltage, and then you look at the size of the wires that are included with your motor. So if your motor has thin wires, then it's not intended to handle a high amperage. If it has thick wires attached to it, then it is intended to handle high amperage. So, and you can always look up at the gauge levels and what gauge or AWTG, can handle what current and so forth. But looking at this, I estimate this shouldn't be running at more than 1 amps. If it draws more than 1 amps, the wires will get, either it will just plainly melt, or it will get warm, and the plastic and everything will just become a really soft wire and eventually just wear out very, very quickly. So yeah, that's what we're essentially testing first, is what's the motor speeds involved, and that's our start. Since the motors already start operating at less than 3 volts, I thought it would be just a worthwhile idea just to test to see how this runs on one single lithium battery, one of the, 18650 batteries. Just for the just for as a test. Okay, next up is just to get the motor driver in place. This is not a complicated part, this is just more to get everything assembled and just to see that we're still on the right track. And that's kind of it for this part of the test. And so we can still measure that the total power consumed by both motors now, and also make sure that our motor driver provides output to our Arduino as a controller, and I've added a peripheral just to make sure that there's enough power for everything going around. So okay, at this point we needed some code, which I'll tackle the software in a different video, but essentially here we are just writing code so that the Arduino accepts commands from a serial port, the USB port, and then executes those commands. We just want to see that the motors can turn according to the commands that we give it. This will also allow us to see the orientation of the motors, that they're correct, and if we need to, we can swap the wires out to make sure when it needs to turn left, it turns left, and right, and etc. So there's not any incorrect wiring involved. Okay, so for me, the most complicated part in this project is at this point where I'm working with an unknown component, but IMU is completely new to me. So there's quite a few questions that I have, and we'll build a dedicated board just to tackle this question. Okay, so the question here is, with this module, the compass, does it work? Let's say if you're looking, let's say that is north, the way my finger is pointing. If that is north, does that mean the compass, this device needs to be orientated this way? So if it looks that way, it's north, and let's say that would be south then, or does it need to be orientated this way, so when it looks that way, it's north, and when it looks that way, it is south? So and you can ask the same. Could it be on a side, or is it the side like that? So all of them valid questions. I assume it would be this way, just looking at the mounting hole, but I do want to test it to see both different ways of doing this. So in order to test the orientation of the IMU and to make sure everything is nice and stable, we use this PCB or this proto board as a starting point. So we've got one set of female connectors that's looking upwards, and one set of female connectors that are vertical. One horizontal, one vertical, and that's just so that we can quickly do a test and see which way our magnetic field, or at least our IMU, is affected by the magnetic field of Earth. And while at it, I've added some rails for the 5 volts, 12 volts, and ground to the board as well, just to simplify my life in terms of connections. So okay, not quite a final tank and definitely not a final board. This is more just to test that gyroscope, or sorry, rather the compass. And so I've got the two connection types, one so that it can sit up straight, and another one so it can sit or vertical. So yeah, and then other modules, okay, this I'll just for the moment throw back loose. You know, this is its the GPS module. I'll just throw it at the back, and motor driver, just for now, just to keep everything together while testing. I've glued it on there, same with Arduino, and so we'll do a couple of tests like that. So after doing some tests, running the example code and seeing what the compass reading gives me, I can confidently say that this is the correct orientation for the IMU. Next up, I added space for the GPS, which is very, very easy to use. And then the more complicated one, which I was also expecting a lot of problems with, is the SIM 800. Now there's a lot of information on the internet about people having problems with it, and I'll make a separate video regarding it. So you'll see there's some extra components on here. That was just to try to cater for the to provide enough power to the correct power to the SIM 800 unit. But that I'll leave that as a video on its own. So there's some challenges involved with it, but it all just comes to making sure that it has enough power to transmit and receive, because it will work if you just turn it on, but if you don't give it enough power, it won't actually connect to a network as such. So at this point we have a robot that operates from battery, receives its commands from the internet, and reacts upon that. Our next step would be to make our robot find the path that it needs to take between two GPS locations. Currently, our robot is just reacting to a command, and one of the commands we're giving it is to face a specific direction in the world. So no matter which way I turn it, it's going to attempt to face the same direction. Now you'll note, due to our components, well, at least look here, if you want a more accurate robot, it usually comes down to purchasing more accurate components and sensors. So at this point you'll see some of the limitations. Okay, some of it has to do with code, but you'll see the limitations where our robot is set to turn to a specific direction, and it will continue to try to stay at the direction, but it's not. Look here, at one moment the reading will say it's facing, let's say, 230 degrees in the world, compass wise, and the next reading, even though it's not changed direction, it would say it has read 270 degrees. So there is a tolerance of, let's say, about even up to 50 to 60 degrees with a compass that we're using. So this will be the starting point for our next phase, where we make our robot go from point A to point B according to a path retrieved from Google Maps.